Alright, so eventually क्या होगा भाई आपके पास, eventually you would see that इवेंचुअली आपके पास क्या होगा, इवेंचुअली आपके पास एक्सेलरेशन जो है ज़ीरो हो जाएगी, रिजल्टेंट फोर्स भी आपके पास ज़ीरो हो जाएगा. सो हो क्या रहा है, कैसे इसको लिखना है देखिएगा. जैसे स्टार्ट हो रहा है, स्टार्ट पे ये रेस्ट है, रेस्ट पोजीशन पे है. एज इट गोज़ डाउन इट वुड एक्सेलरेट, इट्स स्पीड वुड इंक्रीज एंड देन एज द स्पीड इंक्रीजेज तो क्या होगा, स्पीड इंक्रीज होने के साथ साथ इसकी एयर रेजिस्टेंस भी इंक्रीज होगी. सो एज द एयर रेजिस्टेंस इंक्रीजेज देयर वुड बी अ पॉइंट व्हेन द एयर रेजिस्टेंस बिकम्स इक्वल टू व्हाट, equal to the equal to the driving force, equal to the forward force, equal to the accelerating force, and eventually then आपके पास एक constant velocity आ जाएगी जिसको हम terminal velocity कहते हैं. तो लिखिएगा इसके लिए कुछ इस तरीके से. speed of the child increases, speed of the child increases due to gravitational pull or due to gravitational acceleration. As a result, air resistance increases, becoming equal to the forward force or driving force or accelerating force. You can write any of these terms, and hence a constant speed, this is the terminal velocity, is reached. Alright, उसके बाद at t is equal to 26 seconds the front of the sledge is 35 meters from the wall. Determine the distance between the front of the sledge of the wall and the wall when the sledge stops. So 26 seconds पे front of the sledge कितना दूर है wall से, 35 मीटर पे. This is 26th second, right? 26th second. So 35 meters दूर है. Now it's saying that determine the distance between the front of the sledge and the wall when the sledge stops. So when the sledge stops, you need to determine that distance. Total distance between the sledge and the front was what? It was 35 meters. Now the distance it has covered to the sledge until it stops is how much is the area under this graph, because it's a speed time graph. So area of the speed time graph would give you what? It would give you distance. So this distance is equals to half into base into height. What is this height? This height is 12. So this would be 14, this would be 13, this exactly would be 15, and then this would be 15.2. This would be 15.2, right? So then 15.6 and then 16. So 15.2 is the height. So acceleration distance would be equals to half into, and what is this base? This is 28, this is 30, so it's 4. So half into base, that is 4, into height, that is 15.2. So please calculate this, put this in your calculators. Alright, so please tell me the value. क्या वैल्यू आ रही है? It should be something around 30.4. ठीक है, 30.4. ठीक है. So अब आपने क्या करना है, 35 से माइनस करना है. 35 minus 30.4, or you could even directly write it as 35 minus half into 4 into 15.2, and your answer would finally be 4.6 meters, right? उसके बाद कह रहा है at t is equals to 26 seconds the child and the sledge begin to decelerate. Determine the size of deceleration. So you need to find deceleration, you need to calculate deceleration. Now you know that deceleration is negative acceleration, that is again the slope of the graph. You know it's coming from 15, it's going from 15.2 meter per second to 0, and the time you already know is 4 seconds, so simply apply that. Acceleration formula, it's 15.2 divided by what? Divided by 4 seconds, right? 15.2 divided by 4 seconds. So eventually your answer will become 3.8 meters per second squared. Okay, 3.8 meters per second squared. Now unit लिखना फर्ज है बेटा. Mass of the child is 46 kg and mass of the sledge is this much. Calculate the resultant force the child and the sledge as they decelerate. So you already know the value of deceleration. Your resultant force will be equals to ma, and that is 46 plus 9 into 3.8, and that is what? That would be, I think, 5. So alright, so 46 plus 9, okay, into 3.8, so that's 209, but I'll round it off to 210 newtons. So 210 newtons unit लिखना ज़रूरी है. State the energy transfer that is taking place as the child and the sledge decelerates. The child and the sledge decelerates. So initially it has both potential energy and kinetic energy at the top. So I can say that energy is transferred to thermal energy. Energy transferred to thermal energy, and it is being transferred from what? From both kinetic and potential energy, gravitational potential energy. So energy is transferred to thermal energy from both kinetic and gravitational potential energy. Gravitational potential energy, you can write just one of them as well. You can get half for that, but that's how in total it is. So at t is equals to 26 seconds, when the brakes first applied, the child jerks forward on the sledge. Explain why. So initially when this child is moving, he has some inertia, he has some momentum, and inertia, inertia is basically doing what? Inertia is resisting change in state. So if it's in motion, the inertia would not want it to stop, and if it would have been at rest, the inertia of this object would not have wanted it to move. So you would just simply write inertia of the child resist change in motion, resist change in state of motion, so it would want keep going on, right? Change in state of motion, so it would want keep going on, and that inertia is due to his mass. So you can just elaborate further on that inertia of the child, inertia due to mass of the child, mass of the child, resistance, okay, resists change in state of rest or motion. Okay, उसके बाद the next question is, a parallel beam of light is incident on a glass. The beam is perpendicular on the lens as shown. This dashed line P indicates the position of the lens. The center of the lens is dot C. What do you need to do? The lens is a diverging lens, so indicate the shape of diverging lens. Remember, diverging lens is curved inside from both sides. Okay, so this is how a diverging lens would look like. Draw the path taken for each ray. Okay, the first ray would go undeviated as it crosses to the optical center. Either it be the diverging lens or converging lens. In both the cases, the central ray go undeviated, and this ray would go like this. Alright, so diverging lenses are used to correct the short side. Simplified diagram of short side eye. Light from a distant object strikes the eye lens and enters the eye. On figure 8.2, continue 3 rays in the eye until they reach the back of the eye. Until they reach the back of the eye. Assalamu alaikum. Walaikum salam. Alright, so sorry. Figure 8.2 is a simplified diagram of a short-sighted eye. Light from a distant object strikes the eye lens and enters the eyes. On 8.2, continue the 3 rays in the eye until they reach the back of the eye. So, you would pick your scale. Right, this is the first ray. Then this ray would bend. This ray would go there. Alright, so here's where the rays would meet. Alright, so बिल्कुल straight पहली ray undeviated होगी, ठीक है, central वाली ray it will go through undeviated and उसके बाकी 2 rays जो हैं वो converge हो जाएंगी एक point पे. Then it says state how the image of the distant object detected by normal eye differs from the image detected by the short-sighted eye. So an image detected by normal eye, how would it be different from the image detected by the short-sighted eye? So the image would be sharp. Image would be sharp. जो normal eye image देखती है सही proper image होता है तो the image would be sharp. The image would not be blurred. ठीक है. उसके बाद आपसे कह रहे हैं explain how a diverging lens corrects the sight of a short-sighted eye viewing a distant object. So भाई डाइवर्जिंग लेंस कैसे करेक्ट करेगा? डाइवर्जिंग लेंस क्या करता है, जो लाइट रेज आके स्ट्राइक कर रही है आपकी आँख को, अगर आप यहाँ लगाओगे डाइवर्जिंग लेंस तो ये क्या करेगा, ये इन लाइट रेज को क्या करवाएगा, डाइवर्ज करवाएगा, इन लाइट रेज को ऊपर उठाएगा एंड देन जाके जब वो आपकी आँख पे फोकस होंगी तो आँख उनको वापस से कन्वर्ज करा देगा. तो हाउ डाइवर्जिंग लेंस करेक्ट्स, सो आप सिंपली लिखोगे द डाइवर्जिंग लेंस वुड diverge the light rays before they enter the eyes. ठीक है, diverging lens diverge the light rays before entering the eye. Before entering the eye. Focal length of the lens is given to you as 4 centimeter. Height of the object is 3.5 centimeter. It's placed 6 centimeter from the center of the lens. Full scale diagram. Drawn grid on which dashed line L represents the lens and okay. Arrow the object. So by drawing figure 8.3, find the position of the image of the object O. Draw image I and label it I. So draw the image I and then you have to label it I. Right. So see, the first rule for all lenses, let it be diverging lens, converging lens or whatever. The first rule for all the lens is that you need to pass the first line from the top of the object through the center of the lens, and that line will go undeviated. That line would not change direction. Right, this is the first line. Then you need to bring the second line, and that line should be just parallel to the principal axis from the object, again from the top of the object parallel to the principal axis. So this is the line parallel to the principal axis. Okay, what is the principal axis? This is the principal axis, the line that passes through the center of the imaginary line that passes through the center of the lens. Right, the imaginary line that passes horizontally through the optical center of the lens. Now they have given you that focal length is 4 centimeter, and you can see the scale. 1 centimeter on x-axis is 1 block, and 1 centimeter on y-axis again also 1 block. So if I talk about the focal length, since it's a diverging lens, 1 right, so 1 2 3 4 boxes, that means 4 centimeters. So this is the focal point, this is the focal point. Similarly 1 2 3 4, this would be the other focal point on the other side if it's diverging lens curved on both sides. Alright, now see, the light ray would diverge, but when it diverges it would eventually come back it can be traced back virtually, and it will pass through the focal point. It will pass through the focal point. Alright, so this light ray is going to virtually pass here, right, and this would have been diverged like this. So that means the light ray meet here, the light ray meets here. The point where the light ray meets, this point, this is the image, this is the image eye, this is the image eye, right? So this was the object, this is the image. Now explain whether the image is produced is virtual. It's definitely virtual because the real light rays do not meet. It's virtual because it cannot be projected on a screen as well, right? So, or you can say it's formed on the same side of the lens, so virtual. And वर्चुअल इमेज की डेफिनेशन क्या होती है हमेशा, इट कैन नॉट बी फॉर्म्ड ऑन अ स्क्रीन. अच्छा जी, उसके बाद क्या है, उसके बाद से कहता है write an E in a position from which an eye can see the object. So from where can the eye see the object? Definitely your eye should be placed somewhere on the right hand side, right? So your eye can view the object over there. Then it says that determine the linear magnification. So linear magnification is image distance upon object distance, image distance upon object distance, or image height upon object height, image height upon object height, object height. So if I talk about the image height, it's 1 centimeter till here, then 1.1, 1.2, 1.2, 1.2, and if I talk about this one, this is 4, this is 3.5, this is 3.5. Alright, so 1.2, 1, 1.2, 1.4, okay, 1.4, 1, 1.2, 1.4, 2.6, 1.8, yes, it's 1.4. So 1.4 upon 3.5. Calculators, please. If you calculate this, your value should become something around 1.4 divided by 3.5. That's 0.4. That's 0.4. So this is the magnification, and this is less than 1, so it means the image is diminished. The image is diminished means this is smaller than the object. Okay, then moving towards the end of the paper, power supply in an electric circuit is a battery of EMF 12 volts. Two ways in which the EMF of a battery differs from an alternating current of the power supply. So see, it would not be changing direction, it will always be positive, and its value would also not be changing, it will always be a constant value. So it will always be positive always, right? Value of EMF is constant, right? उसके बाद क्या है, the circuit includes 3 resistors and 2 open switches S1 and S2. YZ is a straight line, is a straight horizontal section of connecting wire that lies between two magnets. S1 is closed now. Calculate the current YZ. Calculate the current in YZ. So S1 is closed and this is right now open. So I can just simply say that this circuit is the 20 ohms and 28 ohms, both of them are connected in series, right? So current would be what? Current would be voltage over resistance. What is the total voltage? It's 12. What's the total resistance? 20 plus 28, that is 48. 1 upon 4, so that's 0.25 amperes. 5 amperes. यूनिट लिखना ज़रूरी है और आंसर भी यहाँ लिखना उससे ज़्यादा ज़रूरी है. Explain why YZ experiences a force. So basically YZ is placed in a magnetic field. YZ is placed in a magnetic field, and as an electric current passes through YZ, the field of the wire interacts with the field of the permanent magnet and hence experiences a force. So YZ is in a permanent magnetic field, is in a magnetic field, and when current flow through YZ, what would happen? When current flow through YZ, there would be magnetic field of YZ interacting with permanent magnetic field, right? Hence experiencing a force. ठीक हो गया बच्चा. उसके बाद लास्टली क्या है? Tick the box which describes the direction of YZ. Alright, so use Fleming's left hand rule. Right, again Fleming's DC motor, so Fleming's left hand rule. And when you are going to be using Fleming's left hand rule, this is Fleming's left hand rule, right? If I look at YZ, I would find, alright, this is YZ. Now since this is the positive terminal, current is going from Z to Y, so my forefinger should be north to south of the screen. North to south. It might look flipped in the picture, but my north pole, my forefinger is going to point north to south, and then my current is going to point Z to Y. The current finger is going to point Z to Y. So automatically the thumb would point downwards. So that means it would experience a force like this. Alright, so force would be downwards. How the direction of YZ is determined? So direction of YZ is determined using Fleming's left hand rule, where the forefinger represents the direction of current, the forefinger represents the direction of field, and the middle finger represents the direction of current, while the thumb represents the direction of force, right? So okay, determined determined using Fleming's left hand rule, right, where the forefinger represents the direction of field, and the middle finger represents the direction of current, and the thumb represents the direction of force. So you just need to mention that. Forefinger, right, middle finger और and thumb. ठीक है. Forefinger represent क्या करेगी बेटा? Field की direction. Middle finger represent करेगी current को, and thumb represent करेगी किसको? Force. Okay. S2 is closed, calculate the total resistance of the circuit. So if S2 is closed, screen फिर से बात नहीं होगी, फिर चली गई. So if S2 is closed, alright. So if S2 is closed, that means 30 and 20 ohms are now going to be in parallel. So the circuit would be something like this: 30, 30, 20 and 28. Alright, 30, 20 and 28. ये हो गया done. अच्छा, it might be taking some time to load on the screen. Alright, so you need to calculate them in calculate these resistances. These two are in parallel and this other one is in series with them. So you need to calculate 30 and 20 in parallel and then add 28 with them, and when you do that you would eventually get your answer as 12 ohms, right? Okay, next, when talking about the resistance, explain what happens to the force on YZ as S2 is closed. So when S2 is closed, what would happen? When S2 is closed, that means the resistance would be lesser, resistance of the circuit would be lesser, and hence there would be more current. More current means there would be more force, so the force would be greater. And lastly, it says the current in the 20 ohm resistor is I20, current in the 30 ohm resistor is I30. State the value of the ratio I20 I30. So once again, the ratio of the currents I20 over I30 is equal to inverse of the ratio of resistances, that is R30 over R20. So see, this would be reversed. So that means resistance is what? 30 ohms. Resistance, the other one is 20 ohms. 0, 0, 1.5. This is the ratio, right? So we are done with this. Inshallah, in the next class we will do one more paper. Until then, take care. Allah Hafiz. Keep practicing. बस लगे रहो, आपने घबराना नहीं है.